Okay, sorry for the little delay. We will now announce the winners of the hackathon. We have 3 prizes for this hackathon, and I will have the pleasure to announce the 3rd place of this hackathon with a prize of 1,000 euros. And the winners for this prize are Anja Strunk from CloudHit, Christoph Lange and Paul Musman from the Fraunhofer, and Pinan Lakani and Maharshi Sushak from SmartSense Solutions for their hack on advancing the LinkML-based CI infrastructure of the service characteristic working group. So I will ask you guys to come downstairs and present the audience the results of your hack.
Thank you very much. I will take the 1,000 euros later and first deliver. Good that we had 5 participants in the hackathon team, because 1,000 is easily divisible by 5. So let's see. Okay, so our objective was to advance the LinkML-based CI/CD infrastructure that has been used for a while by the Gaia-X working group service characteristics, a working group in the technical committee that I'm leading together with our remote participant Anja. Well, 2 other on-site participants are here, Paul and Maharshi, and Maharshi's colleague Pinanka also supported us remotely. So the objective of this hackathon session was to improve the functionality of the CI that generates the technical schemas for the Gaia-X credentials. These schemas are against which all Gaia-X credentials are validated by the Digital Clearinghouse, for example. These schemas are generated from definitions given in LinkML, which is like text-based, kind of human-friendly front-end language, as you will see. Target audience is, the working group, obviously, but then also anybody else who is reusing our schemas, that is, retrieving them from the Gaia-X registry and, making use of them in their applications, but also anyone who is interested in generating their own federation-specific schemas, using maybe LinkML as a convenient tool for that, or even using like cloning parts of the CI that we have in the repository of the working group service characteristics. The focus of this hackathon was, there was actually a long wish list. We had to prioritize. What did we prioritize on? Adding formally unsupported functionality to the tool that translates LinkML to a shackle. And secondly, enabling the definition of complex validation constraints and or logical axioms directly in shackle or in the OWL ontology language. A bit more of a problem statement. So technically, Gaia-X credentials are validated against shackle shapes, and similarly, an ontology is used to define like all the terms to be used in Gaia-X credentials. And in order to do that, you would normally have to know 2 W3C standards, the web ontology language OWL and the shapes constraint language shackle. They are, for beginners, they are rather hard to learn. Here you see a listing definition of some schema defined by the infrastructure sub working group of service characteristics in shackle, and in LinkML this looks a bit more human-friendly. And even before the hackathon, we've had the CI in place that invokes a tool from the LinkML suite to translate this LinkML language on the left to shackle or to OWL or to JSON LD contexts, whatever we need on the technical side. Now, LinkML does not support all constructs that we need to express, to define our concepts, to express validation rules and so on. And therefore, so far, the working group service characteristics and its sub-working group infrastructure service characteristics, they have been unable to fully capture the relevant domain knowledge. And domain experts having domain knowledge, but not deep technical knowledge of the relevant W3C standards, they have so far been able to contribute their knowledge. They have been unable to contribute their knowledge to the Gaia-X schemas. And we've received requests from various Gaia-X projects, including lighthouses, that they would have liked to reuse our schemas, but have not been able to do so, or that they have not been able to make productive use of LinkML for their federation-specific purposes. So we addressed two problems. We fixed two things. We've added two features. Feature one is saying that the value of some metadata attribute should be string A or string B or string C. Something that seems easy. It has not been impossible before. So here on the right you see an example of GPU interconnection types, some like very specific infrastructure service thing. So far it has been possible to say this should be value A or value B, but in a rather cumbersome way. You had to define a new enumeration data type. Whereas actually the LinkML language already supported a feature saying this string should be one in the following list of values, and also the Shackle language has always supported this, but the LinkML tool that translates LinkML to Shackle has not supported it so far. Now it supports it. You can say that right in place, and here in this diff on the right side you see how that we have already submitted that as a merge request to the service characteristics repository. And not only that, we have also like adding the functionality to LinkML was not just done as a hack for the hackathon, but we've already submitted it upstream to the LinkML project. That is actually from the working group and the Gaia-X lab. Several submissions have already been made to LinkML, and that makes a lot of sense because LinkML, as you can see on the right, is an established open source software project with a sizable community. So it will ensure the quality and the sustainability of what we are producing here. That was feature one. Feature two was different, acknowledging or anticipating that LinkML will always have certain limitations. So there is still a list of further constructs that LinkML's modeling language supports and that Shackle or OWL support, but the translators do not yet support it. So we could do further iterations of our first subtask of the hackathon, but as long as that's not been done, well, it might be an easier solution if skilled experts are around to simply write down the desired construct, validation rule in Shackle or in OWL. And then to merge the output of LinkML and the manually maintained expressions into what's published to the Gaia-X registry, as you see below. So we've basically added a way to bypass the generation of LinkML for special cases, whereas of course still we anticipate LinkML to be used for the bulk of schema definitions. There is quite a number of features of Shackle and OWL that will not be trivial to ever implement in LinkML. Well, think of complex things, alternative paths, Sparkle queries, complex OWL axioms. These have been discussed occasionally, but in our latest breaking final fix, we've identified a very easy thing, and this is quite related to the spirit of this building and this location here, multilingual labels. The RDF graph data model has built-in support for multilinguality. LinkML doesn't support it yet. Okay, here you see we have this. We implement this generation both for Shackle and for OWL. And well, the issue with multilinguality in LinkML is the problem is known, but it's been open and unassigned for 2 years. And well, not to say that we fixed it in LinkML. We have not fixed it in LinkML, but we enabled a workaround. We enabled a way to bypass LinkML for that purpose, and that's well, nice contribution to emerge here in this place, because just a few hundred meters away, yesterday, by chance, I discovered that there is a Jardin du Multilinguisme, so the garden of multilinguality, paying, I think, a tribute to the interpreters that are working in buildings like this, also in the European Court of Justice, yeah, now we can also make our contributions. Like as of today, for example, the class service offering now has a label in German, and I'm sure we'll see a lot more multilingual labels emerging. Thank you.
Thank you very much,